Hi, I'm Malcolm and welcome back to my shed. It's been a while since I've done one of these little videos, especially the kind of the engineering ones where, you know, we're refurbing or we're just sort of making components and things like that. But I've got a little project here that has been handed in to me, again by a friend in the village called Martin. And he's working on this kind of project of a motorcycle using various, I believe, components. But this, he tells me, is this rear brake caliper is of a Cagiva Mito 125. And I mean, from the front face of it, it looks okay, but when we flip it over, as you can see there is a screw, one of these actually, which is seized inside there. Now, I'm not a metallurgist, but I'm sure the science behind this, it's almost like a galvanic welding that takes place. And what happens is, because it's the screw steel and of course the caliper's aluminium, there's this, it's just like a welding process that takes place, you know, with the corrosion. So this one is completely broken off and completely seized inside there. This one he's managed to get this one out. But as you can see there, you can see the aluminium in the threads, which means actually that it's picked up the threads from inside here. And if you look very closely, you can actually see it. So we're going to have to do something about this. I mean, the bolt is actually bent as well. So what I'm going to do is I'm going to get you just in a little bit closer now and sort of explain how we're going to fix this, because these are quite expensive components, these. But I believe this is fixable, and I think what we'll use here is these nut inserts, which give a really good mechanical repair on a thread which is damaged. So anyway, I'll get you in a bit closer and I'll explain how we're going to achieve this. So now you're in a bit closer, you can see the extent to which this has seized and broken off. Now, it looks like he's made an attempt here to try and get this out. But you know, you'll probably experience this yourself, is that you can grab so much of it and you've just got to work at it and just try and ease it out. But if it's anything like this one, where it's picked up the threads here, as you can see, this will probably just strip out. So the only way really that we can repair these two holes now, this hole here that's clear, if I put a tap down here, if I can get it started, the tap actually runs through the hole, and it feels like it's actually there's very little play in there. So there's actually very little damage that it's caused. But again, I'm just not keen on this, because this is a critical component. This is your brakes here, and I would be a little bit concerned if I was to leave this as it is, especially the way that it's picked these threads up. So I think really what we'll do is, to balance the whole thing, is we will use two of these nut inserts here to actually fix this caliper. Now, the way that I'm going to do this is it's crucial that you get the center line of the hole, because you know, this has got to marry up with the other side of the caliper. So what we'll do on the milling machine is I'll use, again, and you've probably seen it before, it's a coaxial indicator, and what we'll do is we'll get this completely concentric to the spindle of the machine, and then what we can do then is drill out in stages. I'll probably just use an end mill just to go in there, just to make absolutely certain that we've got a flat spot on the top of this screw that's left inside, and gradually we'll open it out to our tapping size, which this particular drill here is 10.8 millimeters, which will take the taps here, which is the correct thread size for the pinlock nut insert, as you can see here. This thread, incidentally, is a is a 125 thread. Now normally what you would get, this is 12 mil by the way. No, is it 12 mil or is it? Yeah, it's 12. Yeah, it's an M12. Now normally what that would be is 175. So if you're going to do something like this, you need to be careful to make absolutely certain that you get the correct tap for the thread pitch. This is a 12 mil by 125 thread pitch, as you can see there. So pretty important that we get that correct. Once we get this drilled out and we get this tapped out, then the next stage really then is to screw in these pin lock inserts. Now you can see these little prongs that are sticking up here. So how this is going to work is once this threads inside, once this screws inside here, what we'll do is, now I've just made this little tool up on the lathe, and how this works is that this will run down the center of the insert, and then this little sleeve goes over. And what this sleeve really does is to stop the prongs from splaying out, because what we're going to do is we're going to hammer these pins into place, and what that will do is it will lock the insert in that position there. We need to make sure that we've got clearance at the bottom here, because we don't want this protruding through, and also we're relying on, this is a counterbore face here for this this screw to go into. We're not going to be this will not be used again, but there'll be new screws that go in here, and so we want to make sure that there's enough relief there that when this screw goes in, it's mating up with these faces here and can go all the way through. So so I think the next stage now is to get to the milling machine. Let's get it set up. Let's get it indicated in, which I'll go through with through the process with you, and let's get it drilled out and get on with it. So here we are at our mill drilling machine, and I'm going to use here this 123 block, which gives, because it's perfectly machined, and you've also got a machined table as well, you get a very, very good location. It's really stable. And what I'm going to rely on here is I'm going to rely on these machined faces just on this casting, just on there. And if we place this on top, what we've got is a very, very good stable locating point. And it's just now a question of just clamping this by means of this clamp here. I'm just going to bring this further in, and what I'm also going to use is just a little bit of emery cloth on here, just to protect the casting when we bring this down. Just get everything centralized, make sure that we've got plenty clearance for the drill going through. Just get everything centered up. Now I just want to mention before we go any further that I have already checked that the machined surfaces on the back side of this caliper here, which I showed you just a few moments ago, is perpendicular with the holes, the locating holes that pull the two halves of the caliper together. It's absolutely crucial that you make sure, because if this was just a couple of degrees off, then the holes would be at the other side at the wrong position, and that would just end up with the caliper being scrapped. So make absolutely certain that if you're going to rely on a machine surface, that it is perpendicular to the holes that you're going to be drilling, which I'm satisfied it is. So the next stage now is I'm just going to bring this spring-loaded center down here, and what I want to do is I just want to pick up on the center of the tap, and this will give me a relatively good initial center. And it's not far away at that.